All right, so there's three main types of bonds that we have. So we'll just break them up into three small sections. So we've got ionic, we've got covalent, and we've got covalent number 2. And this will be charge. So within ionic one, all that we have is, let's go sodium chloride because that's our standard we always use. So you've got sodium, which has 1 electron. You've got chlorine, which has 1, 2, 3, 4, 5, 6, and 7. Chlorine is way more electronegative, therefore it wants to try to grab that electron from the sodium. So it's going to send going to steal the electron more or less. So you're going to end up having sodium, which is going to become positive because it has less electrons. You're going to end up with chlorine. It's going to end up being negative. So now you've got an electric charge between them. So you can have an electrostatic charge. That electrostatic charge means that the sodium is going to attract anything towards it, which is negative. The chlorine is going to attract anything which is negative towards it. Oh, positive towards it. E.g., they're going to pull each other together. That is going to start to form your bond in between them. So that will be your first bond there. But remember, chlorine can attract anything else which is positive. So if you have another sodium somewhere, that one's also going to form a bond there. And then the other sodiums are going to form bonds here. And then that sodium is going to attract anything negative towards it. That chlorine is going to follow anything towards it. And you end up getting the lattice structure forming. So that's for your ionic bonding, is that you have a direct transfer of an electron over to another one, and then the fact you have different charges, so diff charge means that they're going to attract each other. For your covalent, like in carbon, in here what you've got is you've got very similar electronegativities between everything. So you have similar electroneg, which means that you're not going to have any charges overall. None of the atoms are going to want to steal, or none of the atoms are going to want to steal the electrons more than the others. So you're going to get an equal distribution of where the electrons want to live as they're being covalently shared between everything. So you've got your first carbon in the middle, and it has 4 free electrons, which it can gain or it can lose to be able to get to a happy state. If I have another carbon, which is, damn it, when it does that, I can't get rid of it, I don't think. Yeah, there we go. So have another carbon. I'll make this one with a red. They've both got electrons that they can share. So this one's going to share over here. That one's going to share over there. Over here, I'll have another carbon. Another one here and here. These can have an electron to share. And these are also going to share their electrons. So as they are all sharing their electrons, you have a nice distribution, which means that they're all going to be sharing with each other. As you add more carbons to it, they just keep doing the same thing. So you end up getting another new lattice structure forming, similar as what you get with an ionic compound. That's why, and this is a really strong bond as well. So it's really, really solid because it's a physical bond which is electrostatically holding everything together, which makes this a really, really solid structure. Hence why carbon has a really high melting point, because it's really hard to break these. So hard to break these ones. So that means high melting point. And this is because you're sharing electrons. So share electrons close electroneg. And And then finally, the second type of covalent bonds that we have, this is what happens between different nonmetals. So the most normal one that we have, or the most common one that we have, is for water. So here we have different electroneg. Therefore, we have electrons hanging out more with one of the atoms. All right, so let's have a look. So we've got water. So we've got H2O, H, H, and O. This is just like a thing that happens that it goes this direction. So hydrogen has 1 electron. Water has 2 valence electrons that are out here. And they're going to have 2 more. So these ones here are sharing with each other. So it's grabbing another electron from each other. So now it's going to have that. But water is more electroneg. So therefore these electrons are actually going to hang out more over near the oxygen. And that means that hydrogen is going to have a small positive charge and our water, or our oxygen, is going to have a small negative charge on it. So because we have a small negative charge and a small positive charge, I happen to have another conveniently placed water molecule over here. Remember, our oxygen is going to be slightly negative, and because of that, they're going to be slightly electrostatically charged. It's not going to be the big charge where it's like a completely, I've lost everything from here, so I'm fully positive, and this one's going to be fully negative of having a full electron. It's just going to be, instead of it hanging out right in the middle, instead of my electron being 50% 50, it might be like 75% over at oxygen and 25% here. So I've got a little bit more charge, but not a full amount of charge in comparison. And if I had another water molecule over here, that water is also slightly negative. This proton is also slightly positive. And they're going to have a little bit of a charge between them holding each other together. So that tiny little bit of electrostatic charge between everything, we call them a hydrogen bond. This is a hydrogen bond. And this means that water actually has a high boiling point than, or high melting point than most other non-gases, like covalent compounds. So if we have a look at carbon dioxide, that's a non-polar molecule. So carbon dioxide, which I'll do here quickly, because it's a straight bond, you end up having equal charge distributed along it, so it's going to be non-polar. And that means that it doesn't have these extra special bonds between them, so then that's going to evaporate, or it's going to melt a lot quicker, so you're going to end up having it as a gas the whole time, whilst water at room temperature is a liquid, as we know. So that's the general gist of what's going on with our different types of bonding. So hopefully that helps you.